Hello and welcome to drillingcontractor.org. I'm Alex Wuckman and we are here today with John Bloomfield, founder and president of Bloomfield R&D. He just gave a presentation at IADC's Art Spark Tank about his no-pull drill bit. First off, I'd like to welcome you to drillingcontractor.org and I want to thank you for taking the time to meet with us. Now, what inspired you to develop this drill bit?
Well, first, thank you for having me. About 10 years ago, I was watching Modern Marvels on television. It was about oil rigs and oil drilling. And I really didn't know what it was about. And after the hour show, I said, my gosh, that's what I see in all the stock photos and pictures of these guys wrestling with this pipe and the activity and the hyperactivity of fighting this stuff. And I said, now I get it. They're either putting pipe on or taking pipe off. And I said, that really doesn't make any sense to me because it looks like the majority of the time is spent not drilling a hole, which is what the whole purpose is all about. So as an inventor, and being an inventor for over 50 years, I started thinking about, well, how could we do this better? And the advantage that I had is I had no prior knowledge. In other words, most inventions come from, not from shops that we've been doing it this way for 50 years. I was totally ignorant. But I put a couple things together. And I also, when I invent, I always use proven technology. Most successful inventions are technology that has been out there 50, 100, 250 years, and you just mash that up together and combine that into a unique product. And that's exactly what I did, is take old technology, put it together, and make a unique product out of it.
What are some of the technologies that you're including into the design?
I'm using traditional PDC bits technology, just the standard there that everybody's making and using today. I'm using explosive fasteners. Now, when I say old, that's old. Our jet canopies on our military aircraft, when the pilot has to eject, those canopies are held down by exploding fasteners. Why? They're reliable, very, very reliable. They happen instantaneously, and they will get the canopy away from the pilot immediately. So I'm using exploding fastener technology, again, which is old and proven and reliable. I'm also using technology, and I'll show you in a second of the model, that we're going to explode the tip.
Can you show us the concept of how this works, how these would work?
Absolutely. This is just a stack up. And what we have here is a model, a 3D model of a typical bit. And what happens is we're going to communicate with this bit. It's drilling away, down in the hole, drilling away. And we're going to communicate with this bit when we realize we're going to have to change the tip, the bit. We're going to communicate with ultrasonics. And that'll just be an ultrasonic transducer on the top of the drill string. And it will communicate with this mandrel. This mandrel will have a little module in it that's got some ultrasonic transceivers in it.
Okay.
Old technology. In fact, I have patents on ultrasonics, so I know this well. And all it's going to say is, hey, it's time to change this bit. When that happens, after some security codes and that sort of thing, the exploding fastener will liberate this whole tip. This whole tip comes away. It becomes liberated from the rest of the bit and the drill string. The operator will pull the drill string up, and this bit will be floating in the mud or sink to the bottom, depending on time. But this whole shell right here now knows that it's been liberated. And with a timer in here, say 15 seconds to a minute, 2 minutes, whatever's appropriate, then this piece will explode. Now that, again, is the old technology I was talking about. We talked about old technology with exploding fasteners. Now we have old technology in exploding this metal shell. When I say old, I'm talking 500 years. Back to Christopher Columbus days when they lobbed cannonballs at each other, that was a metal shell with explosives in it that fragmented. Because all I want to do is fragment this. I'm not trying to do any big damage, I just want to fragment it into something about this size. So once this whole thing is fragmented into this size, then we lower the whole bit and drill string back down into the hole. We do not rotate. We turn on the high pressure mud, and we flush, maximum flush, and we start washing these little fragmented pieces of this. We wash it back up the drill hole. After about 3 or 4 minutes, all the fragments should have been washed up sufficiently up the hole that there's nothing still left in the bottom of the hole to dull the new cutters. Because what has happened here is now you have brand new cutters. This piece right here. So they're just like the other one, but they're brand new and sharp. Once you have the fragments washed up in 3 or 4 minutes, you start rotating again and you're drilling again. And now instead of a day or 2 days of downtime, I put you down 5 minutes. I mean, you save 2 days out of a week. The industry knows the numbers better than I know them.
Oh, yeah. The explosive bolts, it's like, could you give me a little bit more information about how that would work? And
This, for instance, would be an exploding bolt. All they would have in there is just a little tiny C4. They'd drill it out like an eighth of an inch little C4, and all it'll do is fracture it. So the explosion thing is a sexy word to use for this, but in reality, all we're doing is fragmenting things. It's also used in the space shuttle. There's huge bolts and nuts that hold the space shuttle down. And when the right signal from the computer is we're going to have a launch, then they will explode those nuts. And they don't explode violently. What they do is they've got them so engineered and scored in such perfect ways that the nut just literally almost falls apart, just falls. You wouldn't categorize it as an explosion. And it's the same thing. We're just going to take this fastener and we're going to explode it to the point where it just doesn't hold this anymore. And these, when we explode them, we're not trying to do any damage like you would think of the battlefield type things. We're just trying to fragment this. Okay. And what you would do, and again, you see now I've got 3 cutters on this particular model. So now I've saved 3 trips. It's the interlocking that's the secret here. The fastener that holds it together is not going to be structural. It's not going to try to take the torsional load or the pressure load. It's just going to hold these pieces together. This is a stack-up model. And the way this is engineered to fit to the next piece is where the real engineering comes in. And the different alloys of metals that you're going to have within here and the different scores that you'll have in here, all that will be precisely engineered so that this thing fragments to the level that we can wash those old pieces up. The nice thing about it, though, is once you've got it down once, you'll have it down forever because nothing changes.
What is the next development phase? Where do you see this model? Where do you see this technology going from here?
I think it's going to have to be a collaboration of folks that really know that particular area. For instance, one of the top bit manufacturers needs to contribute their bit knowledge and metallurgy knowledge and things like that. I visited Southwest Research Institute. They love this project. They're explosive people over there, nutso. They just like to blow things up. They tell me this is a piece of cake to interweave inside this metal cone certain channels and things like that where this will fragment the way they want it to. So you'll have to involve those folks, maybe some industry-wide people. I know that there's some programs called Game Changer at Chevron and Shell. I think to get those people involved in their overall knowledge of everything and some possible funding. My part would be the electronics and control side of it. I'm ultrasonics and the general driving of this whole project. So I think it would take a collaboration of the best put together as a team, and this thing could actually end up in a hole. One more aspect to this concept is that once the tips, and this can be multiple tips, once you fragment these tips and wash them up and begin with a brand new tip, at the very end of the day, you could explode this last mandrel tip portion and wash these fragments up, and you don't even have to pull an old bit out ever. In other words, it's totally disposable. What you've done is drill a hole, you've eliminated 4 or 5 trips, and at the very end, you have no bit left at all.
I want to thank you for taking the time to talk with us here at drillingcontractor.org. I want to take time to thank our viewers. You'll be able to find more videos about spark tank and other drilling techniques here on drillingcontractor.org.